How's the audio levels? Okay, looks like I'm here. Let's see. I said right at 8 p.m. About 1 minute off from that. Uh, well, let me go ahead and just start covering some things I did while we didn't have a stream. So I just did a few different changes to clean up some code, basically. And for anybody who's curious with that, it was nothing important as far as gameplay goes, but I just split out stuff about like registering combat states into its own like registry function. That is called on in our where is it in our init function for our game state. In this create init character function. So I call that and also set up all these components so we can easily add new components without having to like copy this boilerplate code to multiple entities. And that just gets called for every single entity we want to create or every single character. And it's called create and init one character. So I did that. And then a few minutes ago, I just finished implementing some debug code. It wasn't nothing crazy. Just allows us to pause and frame step the game. I'm going to pull it up real quick just so you can see it for anybody who's interested. Well, I guess we're right at 9 here. So, hey, everybody's doing. This is the Zig fighting game development stream. I don't know what number we are on, but we're quite a good ways into it. How's everyone doing? Having a good morning? Probably good evening for most you Americans out there. Yeah, so today we're going to be covering hit stop and maybe hit shake. Along with that, I'll be adding a jump action, possibly a walk back action, so we can test various aspects of hit stop, such as pausing the physics simulation, pausing animation update, pausing timeline for the character actions, things like that. Anyway, as I was saying to everybody before the stream officially started, I added this new debug feature. When you press F3, the game will pause. Hopefully you can see that. And now there's a debug frame counter that shows us clearly how many game simulation updates we've run so far. When I press F2, it steps one frame at a time. And if I hold forward on the character, you can see how they walk forward one step at a time. And then I can pause, unpause, and pause again. That's how that works. This is going to help make it very clear what we're doing with hit stop. Without that, it's going to be kind of ambiguous, especially since we don't have any animations yet. Oh, cool. So, yeah, before we get really started here, I'm just going to post links to our development-related, our repository on GitHub and a link to our Discord server for anybody who's interested in chatting about, just this project or Zig or, fighting game development in general. So yeah, let's go ahead and put that in the chat. Great. Okay, sweet. Okay, cool. So yeah, let's look at our planning document. I don't want to look at the changes. I just want to look at the document itself. Okay. Okay. Yeah, so what we got for today, I already did the support debug frame step thing. I want to add a backup state. I want to add a jump state, a jump physics state too. When we do a jump action, we need to support, of course, the moving through the air, but also when they touch the ground, they need to return to idle, right? That's neutral idle. I'm just put idle here. And then we have to handle not only when we get to the hit stop stuff, we have to make, of course, the reacting player. They're going to basically pause for a set number of frames, and they're going to continue their simulation. It's going to be the same for the attacking player. And for now, we're going to make both the attacking player and the defending player, reacting player, go through the same number of frames of hit stop. So they'll be paused at the same time. Their physics simulations will stop in place for X number of frames. And when those number of frames are done, they'll continue on progressing through their animations, through their physics simulations, et cetera, et cetera, et cetera. And I just wrote down here because we're going to have to actually support pausing the timeline updates. That's like the action counter and stuff. And then physics updates as well. Okay. So, yeah, you know what? Let's go ahead and do a backup state. The reason I want to do this is because I want to be able to like precisely control where the character is. So currently, if we look at our common states, right, did we have that open here? Yeah, we just have standing. Is there a quick collapse all on these? Standing, walking forward, attack. Actually, if you look here, it's probably easier to look at outline. Yeah. So we have our standing, we have our walking forward, we have our attack, we have our crouching, reaction. So we have a walking forward. Let's just make a walking backward state. So the first thing let's do is just basically copy paste this whole thing and make a new state. And that's a walking backwards. And so far, let's just copy paste this boilerplate stuff so we can like debug all this stuff. Forward, backwards. So the difference is so what we're going to change for walking backwards basically is instead of adding to the velocity, we'll subtract from the velocity. So there's one thing to notice here is right now we're just changing the velocity directly. There's no facing concept yet. So the player 2 can't really walk forward and backwards. Their physics would be needs to be flipped, right? So we're going to add, in the future, we're going to add like forward concept, right? So anyway, look forward to that. But for now, we're just going to do this so we can control precisely where the character is moving. Okay, and we just need to go through and do all the boilerplate stuff for that state. So if you copy paste here, we can see we have done a lot of stuff. We have this walking forward callbacks, and then we have all this nice stuff. So let's go ahead and just go through each step here, right? So let's copy paste the walking forward action data in our character data file, our character asset file. Hey, Mighty Sandwich, what's up? Thanks for dropping by. Appreciate it as always. Okay, next thing, again, kind of boring, but we'll have to do it anyway. Copy paste all this boilerplate. So I kind of like a weird difference between walking forward and walking backwards, walking forwards. I'm just going to correct that real quick so it's consistent. Should be walking backwards, walking forwards, but just to remain consistent, I will change that real quick. So yeah, walking backward, on update walking backward, walking backward. Okay, and the name of it is walking backward. Real quick, let me just jump back to where we were to make sure that in common states we call it walking backward. Okay. And walking backwards. Nope, walking backward. Okay. And we had to add, of course, an ID, a common state ID, right? Okay. Let's see. Going back real quick to walking forward. Let's look for that boilerplate again. So we did all this. We made a walking backward callback, etc. We need to add the state, of course, to the character using our handy little new register action states function. That's there. We did that. And any other no, we already did this boilerplate. We did this boilerplate. I think we're good. So let's go ahead and run the game. Whoops, stop it and rerun it. Okay. So we don't have the backward state triggering from anything yet. We need to actually add it to our input handling. So that's fine. First we need to go look at our input code here. So we have up, down, left, right. We do have a left trigger. Right now we have a right trigger. Just go find where we're using that. There's a lot of code. I want us to look at my functions. So let's make that. Yeah, here we go. So what is that about? Oh, yeah. So yeah, we have to make sure this is left instead of right. In the future, we're going to have a higher level input system that will have like a forward input and a backwards input instead of a right and left. But for now, we're using right and left. Okay. So we also need to add an exception for backing up. I'm going to make backing up or walking forward the priority. Why is that a space there? So this is going to be left. Then we can be walking backward. Okay. So that should be it. We should be able to actually execute the walking backward action. Yep, hold left, it goes walking backwards, walking forwards, etc., etc., etc. So we can position much easier there. And again, frame step, if I want to do that, I can do that. Like that. Okay. Great. So we have that working. Just to jump back to our planning document. To the backup state. We got that done. Okay, cool. So we can see how the boilerplate can be added easily for a state. Now we have something much more tricky. We have a jumping action, right? So a jumping action, we should have that in our common game states. It's a state machine we have. I don't want to look at that one. I don't like that view. I want this view. I don't want to look at the working tree. I want to just look at okay. Oh yeah, it's outline. So yeah, so we have a jump common ID. So for now, we're gonna make jump a single action. In the future, we're gonna probably split it up into multiple things like jump start, while jumping, jump landing. So that's gonna happen for sure. Okay, so going back to our common states, I'm going to add it after walking backwards. So the reason I'm going to add a jump state for this thing because I want to demonstrate, of course, the physics being paused while hit stop happens. So we're going to call this one jump, of course. So jump's going to be interesting. It's going to have phases. It's going to have eventually it's going to have the startup when it's on the ground and when you're landing. But unfortunately, well, for now, we're just going to do the arc. And once you touch the ground, you're going back to idle instantly. Also, I'm going to support attacking out of the jump. So, yeah. So we don't need any of this input stuff here for jump. We will need what we need. Oh, yeah. So we need the physics control. So on start, the important thing is jump is going to have some initial velocity, right? It's going to have some velocity. So when we jump neutral, we're going to have some initial velocity. And that's going to be, I don't know, it's just to say 2,000. So actually, we're going to have to implement 3 jumps. 1 for forward, 1 for back, 1 for neutral. Another way we could have done it is use the same action, but set up some state that indicates which jump it should be. I won't say either way is necessarily better, but I tend to have separate jump states with common code for the physics and just have the initial conditions separate. So jump forward, all it's going to do is implement a different on start, effectively. Yeah. Okay, let's see. Okay, so we do have the initial velocity set to something. Might be we'll get to that. We also need to set fixed component dot acceleration is going to be some value. I don't know what good value is right now. I'm just guessing off the top of my head. It's going to be, since it's acceleration, it's changing velocity per frame. So, if I set to 200, that means after 10 frames, this velocity is going to be 0, right? And say we want it actually to last longer, 100 frames. So instead of it being 200, let's say 20. Okay. So yeah, we're just going to do that for now. Just make things, and we're going to adjust based on feel. Okay. And then on update, well, let's just go ahead and do the boilerplate stuff real quick. On in, we're going to return to idle, but we'll have to have some code for when it goes to the ground to return to idle. We could put that on update. Let's get rid of this. So yeah, one thing to do is we can go, yeah, we could do something like this. So having condition and return to idle, and given some condition, what is that condition? The condition is passing through 0, right? Or, so let's see, if context.physics component.position.y is less than or equal 0, then we return to idle. And we're going to make sure to reset the acceleration on that stuff so that we don't keep falling to the ground. That's an important thing. So we make sure the position is 0, dot velocity dot y is 0, and the acceleration is 0. So that's our basic jump physics right there. I think we already implemented acceleration support in the physics system itself. If I'm correct there, we can double check that though. That's collision system. I don't want the collision system. I want the game simulation. Okay. And then we have physics system. Okay. Yeah, so we have acceleration applying to everything here. Cool. Fantastic. So, okay, let's continue with our jump state. Back to common states here. So we did the physics. We did the initial setup for the physics, right? And we could also put this stuff in here, but jump might be interrupted by other things. So we don't necessarily want to reset the physics every time jump ends, such as attacking, right? Attacking still needs to do the same kind of physics. So when you're jumping through the air. And actually, speaking of that, I'm sorry, I'm jumping around a little bit. Just continue with that thought. When you're attacking, you're still going to continue with those physics properties, right? The thing is, we normally would have separate attacks for air and ground. Right now, we just have a single attack. So this is not necessarily the right thing we'd be doing, but we're just going to say, for now, if the position is greater than 0, we're going to transition into the jump attack and not idle. Okay, so we're having a little bit of extra code here for attacks. And we're probably going to split it off into separate things, right? And the other thing is, because we only have one jump state right now, again, in the future, we'll be splitting this off to multiple things. If we're already in the air, we don't need those initial conditions to be set, right? Or at least we don't need the velocity to be set. So we're going to check if the position is less than or equal to 0, then we'll do the initial jump. I hope that makes sense. So okay. And acceleration, yeah, we're going to want acceleration to always be applied when we start. So, okay. So we have those physics laid down. Okay, so now we got to go do the standard boilerplate stuff, right? So, walking forward. Oops. So just going through here, we're going to add a jump in our character data. Jump. Okay, that's good. And then got to add our callbacks, right? Okay. Jump callbacks. Whoops. There we go. So jump, jump. Let's just copy, paste. Jump, jump. Everywhere we see walking forward, jump, jump, jump. Okay. So that all works out there for that. And of course, we got to add the state to our common state registry. So we do that, and we do that. Okay, so that's all added there. The one thing we didn't do yet, though, is have a trigger for it, right? So on standing, if we press up, I want to handle doing a jump. So we're just going to add that here for now. We're going to change priorities on these things in the future, but for now, yeah. So context set input command dot up. We're going to trigger the jump, right? Again, still some boilerplate on this stuff. I'm gonna go through here and clean this up off stream at some point. Okay, so we got the jump. So I think we have all that handled. Let's see how it goes. Yo, Laguno, no problem. What's going on? Appreciate you dropping by. Oh. Undeclared identifier jump in game state. Okay. Where is that? 69? Oops. Yeah. Okay. I had a drink here. Oh, there we go. Oh, okay. Alrighty. So I press up, you can see the characters accelerating up and they stop. What? Their jump is inverted. What's going on here? It's our rendering code. So we need to flip the positioning, right, of X and Y because we're using top left coordinate systems with Y, meaning positive Y being down. That's old school way of drawing graphics because of how monitors used to work. They would draw from the top left to the bottom right. So the way we're going to handle that is, where is our drawing code? Yeah, so we have a draw character. So world to screen. So what we'll have to do is invert this value, right? So that should fix our problem. All the way to jump installs. So you can see we don't see the characters at all. When I jump, they come back up and they come back down. So what's going on? Why is there, did we have initial position that wasn't, so what we have to do is initial position is going to have to be, well, it's 0 as it should be. But the thing is, where's the bottom? Where's our ground line? We're going to have to add an offset to the screen Y, right? So let's see. And let's just going to say 500 for now, right? This is just for drawing so that our world space is correctly converted to the screen space. Okay. So that's what that's going to do. Definitely gonna have jump installs though. That is very important. It's kind of interesting. I wanted to test doing jump installs in they just went off the screen. Oh, I think because my default position is not. Is it too high? What is our screen resolution anyway? Oh yeah, so right. So our initial position is not 0. That's first of all, that's an issue. No, it's a funny story. When I was first like implementing my engine, I was like, how do I do jump installs? Because jump installs are kind of thing where it's like, why would that even be a thing that happens, right? So 500 is too much because I guess our screen resolution is much smaller. What is our screen resolution anyway? I just use whatever default thing we had. Okay, it's only this. So unfortunately, our screen resolution, our game is not screen resolution independent right now. That's something we're gonna have to take care of course. But yeah, let's just so our screen height is 450. So let's make our game. Let's make our offset 400 for a ground offset. Okay, this is just for rendering. It doesn't affect the game simulation at all. It's just so that we can actually see what's going on effectively. Yeah, so there we're at. So we're right touching the bottom there. I want them a little up off the ground, so I'm going to lower that just a little bit. Yeah. So it's looking more and more like a fighting game, right? We have a ground, we have a jump, we can walk forward, can attack. When I jump, I can attack. Oh, I don't have the track triggering on the jump. That's important. So first of all, you can notice that's kind of a really slow jump, right? It's going to last 100 frames is what I set it up for. If we go back to our physics here, right? So because of the initial velocity and all that kind of stuff, well, it's not jump. Where's jump? Here's jump. Let me collapse all those. Yeah, so, 2000 divided 20 gives 100 frames. That's a little slow, right? We want something that's feels a little less floaty. One thing we could do is increase acceleration, cut it in half, see how that looks. This is just kind of like one of those feel aspects of getting things doing good, right? It's a little faster, a little less floaty, but it doesn't go as high. So let's just get our timing right. So how many frames do you think feels good, right? So we went from 100 frames to 50 frames. No, that should be right. So why does it feel so crappy? Well, it's probably because of short distance, right? So let's go ahead and double everything. If we double both, it's going to be the same amount of time, right? Because we're dividing. Yeah. By the same amount, effectively. Okay. It feels a little better. Let's go a little higher. Let's double again. We need to double both sides to get the same amount of time, right? The acceleration and the velocity. There we go. It feels a little better. It's still floaty. And honestly, how many frames is that? So let's pause the game. This is useful. So let's just step a little bit. We're 490. Let's go up to 500 so we can easily count. Okay, I hold up. Frame stepped once. It's at 501. How many frames? Let's just make sure our math is correct. Actually, our math is wrong. I was just estimating because we're subtracting the velocity per frame. So yeah. So we see it was about 100 frames still. So we're going to have to increase our acceleration quite a bit. It's my mistake there to do simple division when it should have been. It's integrated, right? Its value is integrated over time because velocity is slowly decreased and then increased in the opposite direction. We'd have to do some kind of like Euler integration to actually see to calculate the total time. Euler, yeah. Or is it Newtonian? I forgot which integration it is. I think it's Euler, where you're just doing discrete steps instead of Newtonian would be a proper integral, right? Oops, it didn't pop up. What's going on? Yeah, correct. That's what I was calculating in my head, being somewhere around 50 frames. It's just my brain, that's what kind of feels right. Okay. It's pretty good. Still a little floaty. So what we'll do, let's just bump it up to 10 there and 300. No, let's do 2. I want to do that much more. So 260. Yeah. I mean, that's how you read it, Euler, right? That's just how you would naturally feel and read it. Okay. So this is good enough for us to have this kind of physics, I think. So we can just demonstrate concept of hit stop, right? So right now we're not attacking in the air. It's because we don't have the input set up for it, right? I think, right? Yeah. Where's our on start on update? Yeah, we need the attack transition. So I'm just gonna go copy paste that from our jump. not our jump, our standing function. Okay. So we're gonna do an else here because we're doing an else on the position stuff or on the colliding with ground stuff so that we don't want attacks overriding the transition into landing. Otherwise, you'll do an attack and fall through the ground. So we're going to stick that here. And a lot of this code is going to end up being like universal common code that's used for a lot of different things. So we won't actually have it in individual states like this, though I have done this in the past. I have done this kind of stuff where I've had each individual state. That gives you a lot of flexibility. It lets you write really custom kind of attacks and stuff. It really depends what kind of game you're making. If you're making a game with a lot of individual custom kind of actions and states that do things that break the rules, then it does make sense to put this kind of code into each action and maybe have a shared function that you reuse. I think that's a lot of what we did on Killer Instinct. There wasn't a lot of like universal stuff being executed on tick. It was a lot of stuff being per action. So we were able to do a lot of cool stuff. Okay, so if you look in the debug, I can attack in the air. Obviously, we don't have any like indicator of that, but and you just saw the bug I was talking about, fell through the floor. So what's the problem there? So our attack doesn't handle colliding with the ground. Okay, so we're gonna have to do something about that. What we're gonna have to do is, I'm just gonna go ahead and copy this code, and make it a common function, right? And see, let's call it function check ground collision. Okay, and we'll have to pass in a context. And oops. Well, let's just call it not check. Let's handle ground collision. It's probably a better name for that. Okay, so the function handle. So check if when the character collides with the ground, return to ground states. Yeah, this is for now. It's going to be a more generic thing. It needs to be void. This should do what it expected to do. So instead of just doing it in the jump only, we're going to do it in attacks as well. So yeah, we're going to get rid of this. So what we're going to actually have to do is, just so we have an option to do one or else, so we're going to do context here. Right now we're returning void. That's okay. We're going to change it. So actually what we're going to have to do is, I'm going to do this kind of thing. It's not pretty, but we're going to have to return true in this case. Otherwise, we're return false and know if we collided with the ground or not, so that we can handle that case. So obviously, we're not doing anything here. I could do not handle ground collision. Anyway, another thing we could do is just return. So that we skip everything else. We don't do any other transitions if we hit the ground. Okay. So we can do the same thing on, so we have that on jump. On attack, we should do the same thing. Attack priority will be landing and not anything else. So if we're more than 0, there is a case where we're landing, our velocity is less than 0. We might need a handle. We'll deal with that. We'll see if we run into that bug at some point, but that's a good thing to experience. Okay, so yeah. So actually, we'll do this real quick. If this is greater than 0, okay. What's the and? So again, we're sharing all the same attack for jumping and ground states. In an actual fighting game, you wouldn't actually need this stuff in the ground states, right? You wouldn't need in the ground actions, the ground attacks, because we can assume for most fighting games, your ground attacks are never gonna be done in the air, right? So you wouldn't have to have all these exceptions and stuff, or if the y is greater than 0, and you can also assume air attacks also are going to absolutely have to check landing on the ground. So we can simplify this stuff just by splitting off those states into separate those actions into separate states. But for now, we're just going to do this. It might result in a bug because we're not checking to see if velocity is less than or equal to 0, but yeah, honestly, we could do that as well. Yeah, let's just go ahead and do that, simplify things. So if either that's, yeah, let's do, we'll assume that we're falling if our velocity is less than 0, okay. It's less than 0. Oops. Yeah. Okay. So again, let's just double check where we put these things. Whoops. Handle ground collision. So in our attack function and in our, well, this is an attack function and in our jump function. Okay. So we'll return, and the handle ground collision will send us back to standing. Okay. Should be good here. Counter hit hurt box. I'm not quite sure what you're adding about the counter hit, the hurt box stuff, honestly. Okay, cool. So we can attack, and this is why frame step gets very useful. I can press the button for attack, and you can see the attack started in the debug information, and you see the hitboxes overlap here. Step, 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 step. We're going back to standing on start. Sorry. Did we not name that right? Because I see standing on end. That's probably not. Where is jump? Jump on start, jump on end. Oh, did jump on end not get called? That should have been called. Oh, no, attack on end gets called because we're doing an attack, not jump. Okay, cool, that makes sense. Sweet, so we've got the jump physics all set up now. That's cool, and we're only about 39 minutes into the stream, so we got plenty of more time to handle hit stop. Yeah, just let me go and mark that off in our planning document, though. You got jump state, jump physics, got handled triggering of the ground. That's great. Okay, hit stop. You probably saw last time that we had this reaction component, right? I'm just going to stick hit stop in there. Hit stop is just going to be another timer like hit stun. So I'm just going to go ahead and add it to the same component for now. And it's going to work in the same way. We're just going to have a timer that counts down from whatever value we set on hit. So you can see we have the hit stop here. And if we search for hit stun, we're going to set it up in the same place for now. So we have a hit event. We're going to have to set our hit event. It's also going to have a hit stop along with hit stun. So going back here, hit event, hit stun. This way we can transfer the properties of an attack to an event, and that gets applied to the character later. Yes. Okay. Great. So it's going through, see where apply hit stun. So we have this kind of timer code like this, where we just count down to 0. We'll do this kind of similar thing with hit stop. But for now, let's just go ahead and apply it. So we're just applying it to our reaction component for the defending character. We're also going to have to apply it to the attacking character, but we'll get to that. I'll show you how you do that. Okay. And honestly, we could just do that. We can assume we're just going to reuse the reaction component for the attacker as well. So we can just go ahead and just do that. It's going to make things a little easier. Just so we already have that set up. So defender, yeah, we need attacker ID. Yeah. Yeah. Okay, so we're going to apply the hit stop to the attacker as well. Okay, so just going through all the places where we check stun. What was this about? Oh, this was in the reaction. Oh yeah, because we're not doing this in the reaction anymore, so I want to get rid of that. Okay. And where do we deal with hit stun? Okay. Cool. So in our reaction system, we need to go through all the reaction components, and we'll look at hit stun and count down hit stun. But actually, before we start doing hit stun, we are going to count down hit stop. Hit stop is going to override all kinds of timers in the game, including the action timer, animation timers, physics updates. So we're going to go ahead and handle that here. So basically, same kind of thing. If a hit stop is greater than 0, we're just going to count it down until it is 0, right? Oops, and otherwise we're going to do hit stun because we're not going to count down hit stun until hit stop is done. So that's one thing we're going to do here, and that's not a bracket. It is a bracket. It's not a curly brace. Okay. And then same kind of thing, component dot hit stop. It's going to be minus equal 1. We're counting down 1 frame each blah, blah, blah. And we're not going to do anything else except count down hit stop. When hit stop goes to 0, we're not making any state change right now. Okay, so for now, the thing is we don't have any like debug display of hit stun or anything like that. So we could just print it out and that kind of stuff. What I want to do is, what do I want to do? Oh yeah, we can just use a breakpoint for now. So let's go to our game simulation code. Where is that? Oh, here. Game simulation. We're going to go through our game update. Just hit a breakpoint to see how things are going, right? Well, we're not going to set a breakpoint yet. What we're going to do is, oh, we didn't start the game. Okay, let's go. Let's start the game. I made a bug. No, I mean, missing field hit stop. But we don't have that yet. Collision system. Oh, yeah, I need to assign it. Thank you for reminding me, compiler. We're going to say hit stop is going to be pretty long just so we can notice it. Let's just do 10 frames for now. Also, that means all our attacks for now is going to be 10 frames of hit stop. Normally in fighting games, there would be a table of hit stops depending on how strong the attack is, so you have a kind of consistent feel across the game, and overrides in cases where you want more hit stop. Okay, so the first thing we're going to do is set we're going to attack, and then I'm going to frame step until I see we hit a breakpoint. That's okay, cool. We hit that breakpoint, and I want to go back to the game simulation. I want to hit a breakpoint here, frame step, so we can start inspecting what's going on. Okay, so we can see that our reaction components, we can see that hit stun is 25 on player 2, which we accept, and hit stop is 9 for both characters. That's because we've called reaction system once, so we've stepped over 1 frame. Okay, so we're going to step. Oops. We're going to continue. Oh yeah, so I need to unpause actually instead of frame step. Okay, looking back at the reaction components, we count down at 1 frame here. Hit F5 again. 7, 6, 5, 4, and you can see hit stun here is not counted down yet. 2, 1, and now we're going to start counting on hit stun until 0. And it works as expected. So great, that's cool. But you can see like when I attack here, I'm pressing a button. I'm not stopping. In most fighting games, when you hit somebody, physics pause as well, right? So the way we're going to handle that is when you're in hit stop, when you have hit stop, anything greater than 0, we don't update physics. That way you're not sliding around, which looks wrong when your attack is going to stop as well, and it looks wrong for your attack to pause midair and for the character to keep sliding around. It also affects a lot of gameplay balance stuff, right? If you're sliding while paused with an attack and you land on the ground, you're gonna transition back to idle. And also it's gonna look bad. There are games, including Marvel vs. Capcom 3, where you can actually be in hit stop, land on the ground, and your character's like pause for a second. I think Alpha has something like that too. No, I know a few games have that issue, but it's like hit stop carries over to the next action. That just looks completely wrong. You should never really do that in a game, or you want to guard against that, right? Okay, so how are we going to do that? Well, we need to go to our physics system. Our physics system is in just a function inside of our game simulation right now. So what we'll have to do is we're going to look through all the entities, and if game state dot physics component, not physics component, if our reaction components dot hit, oh yeah, entity index, if that hit stop is greater than 0, we're not going to update. We're not going to update this. Right? We're just not going to update that. Actually, so we can see here. Oh, I can't move right now. What's the problem? What did I mess up? Oh, whoops, this needs to be less than or equal to 0. I always do that. We're going to update, so only update physics when there is no hit stop. Okay. Okay. Let's restart the game real quick. And we should see the character pause when I hit until his stop is over, and they're going to continue falling. You can see that. So my hitbox is pretty large. And if I frame step and hit attack, you can see me frame stepping, and then I pause. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I continue on. So that's hit stop effectively. Not too hard to implement. And since we've done that, we have quite a bit of time. I'm going to do something a little fun and hit shake. I'm going to implement hit shake. What is hit shake? In a lot of fighting games, especially 2D ones, to show what's going on, to kind of visually indicate that hit stop, the characters will shake just a little bit. It also gives that little feel of impact. So we're going to have the character shake a little bit when there's hit stop. How we're going to implement that? It's going to be pretty simple. We're just going to add and subtract the visual drawing position of the character when there is hit stop. So let's just jump into our game file, game code, source code here, and we have to draw a character here. We'll give a position. We're going to just like move that position a little bit. Move the position just a little bit when there's hit stop, okay? So what we'll do here is we'll go, we'll just start very simple, okay? So we're going to call it hit shake, okay? So hit shake. That value is going to be, it's going to be some scale, right? We're going to scale it by something. But what we need to do is, I forgot how Zig, in Zig we can do something like this, I think. Game state dot reaction, reaction components. Actually, I don't want too verbose code. So I'm just going to start with hit shake 0 for now. And if game state physics component, we're going to make this more universal, but this is going to be the basic idea just to demonstrate it. Not physics component, but reaction components. 0 dot hit stop is greater than 0. We don't even have to do that. what I want to do is, I'll show you real quick. So we're going to do modulus. So we're going to do a modulus of 2. So every frame is going to like quickly go back and forth. So hit stop modulus of 2. Var hit shake is going to be equal to this. Oops. This is kind of just a quick demonstration. We're going to make this better here in a second. Okay. And we're going to multiply this value. So these are going to be 0 or 1, right? And modulus 2 is taking the remainder of. Actually, let me make sure this is modulus in Zig. It might be something else. Because I haven't used modulus yet. Modulus division. For unsigned integers, this is the same as numerator. Okay. So it seems like we do have that. And we're just going to multiply. This needs to be I32. And we're going to multiply this by our scale, right? So the idea is we need to go on either the left or right side of the character. So we're going to add or subtract, okay, depending on the modulus setting. So the easiest thing to do here is just to multiply it by -1. Well, that's not going to work actually. We need to do, yeah, -1. And then, hold on one second. My brain is, just give me a second here. I'm about to pull up my old code so you can see what I did on other games. Yeah, so we're going to start with a negative value or something. I don't know. Let's just say 10 pixels or something. So it's going to be left, right, left, right, left, right. And it's going to be 20. So it's going to be 10 pixels this side, 10 pixels this side, going back and forth. We're going to multiply that by this value. Okay, that's what I wanted to do. And then we're just going to add hit shake to the vulnerable character. So right now, the only vulnerable character is going to be the one that's hit, which is player 2. This is the prototype code. We'll clean it up and make it more universal in a bit. But I just want to demonstrate what we're talking about here. Oops. Remainder division with I30 and comp time int sign integers and floats must be okay. So you have to use mod, I guess. Okay, instead of doing that, so we're going to have to do mod. I think call mod like this and do 2, I guess. Does that work? Then we don't need all this extra parentheses junk. Why is it coming error there? Remainder division with I30 comp time int. We have to use that function, the built-in function, mod, instead of the syntax. Nice syntax. What are you complaining about? No. Incompatible types. Oh. Oops. So yeah, what I need to do is make it a vector. So what is it? Was it math.vector 2D dot x equals this value, and then y is gonna be 0 because we're not modifying the offset of 0, right? So dot y equals this. Okay. That should work because I think we have addition supported by vectors, right? Oops. I3 does not support struct and syntax. What are we talking about? Where's my brain? Where's my brain messing up here? Oh, because we are I32. Oops. That's why. Oh, and one more thing I forgot. This is screen space, not screen space. This is world space. So we need to make it bigger because draw character will convert it to screen space. Valid operator into binary. Oh, it's doing a different in vector 2D. I thought I imported math into here. Oh wait. I thought we had support for adding vectors. What's going on here? I thought we supported that already. Okay. Oh, wait. Yeah. Oh, forgot. This is not C++. We didn't have operator overloading. My brain is stuck in C++ land. Sorry, guys. That is my bad. I really got to get out of those habits. So instead of doing that, we have, we have math.intVector2.add. So we just add these two things. Or wait. Oh, add is self. Yeah, right. So it's just it's fine. So we just do yeah. Okay, cool. So instead of doing that, we do position dot add hit shake. It's getting a little messy, but should work, maybe. Yeah. Cool. So let's just test it out here real quick. You can see the very micro hit shakes, right? It's because this value is just way too small. Let's make it 2000. Should be closer to 20 pixels. Oops. Sorry. And this should be 1000. That should be closer to the pixel. What? Oh, because I did something. Okay, let's check out the hit shake now. You can see it. It's very quick, right? It's like spazzing out when I hit. So that's what hit shake is. It might be a little too subtle on stream. Just to make it ramped up a little bit, I'm going to like double it. So that's the hit shake. And if you look at any 2D fighting game, you're going to see that. It just gives a little more oomph to the hit. And the cycle, the frequency of the hit might be different depending on the game. Yeah, there we go. I just want to make it extreme so it's obviously that I'm hitting. And if I jump up and attack here, oops, you can see me stepping through when I hit the attack. Am I missing the attack? Whoa. There we go. So you can see when I step, it's left, right, and it continues on. So yeah, that's the hit shake. And honestly, we don't want to have any hit shake when there's no reaction. But that's just to demonstrate the idea. And we'll clean this up. I'll probably clean this up off stream and make it something that's more part of like, we don't have a lot of complex drawing code right now, basically. So I might set up some stuff off stream. But yeah, that's pretty much what I wanted to demonstrate today, I think. We made good time, about an hour. You know, what did we do? We got jump working with all the physics and collision with the ground. We got the hit stop working for both characters. We could be more sophisticated with this stuff if we wanted to be. But for now, I think that just kind of demonstrates the concepts. And yeah, I think that's going to be pretty much all of what I wanted to show. Let's check our planning document. So yeah, we got hit stop for both of these characters. We did do physics. We didn't handle the timeline stuff other than we handled reaction. You know, we handled preventing reaction from updating until hit stop is done. Yeah, screen shake's a different concept, but it is in similar vein of like demonstrating impact. We'll get to camera sometime. That's far off in the future. But yeah, since that's it, if there's any more questions, go ahead and let me know. In the meantime, I'm just going to drop off our link to our GitHub repository that has all the source code we've worked on up to this point, and along with the invite, a link to our Discord for anybody who wants to chat and maybe ask questions about game development, fighting game development, Zig. Yeah. But yeah, we discuss that kind of stuff there. Maybe game industry stuff as well. But yeah, I guess that's it. As always, I appreciate everybody who's come by and watched the stream and participated in the chat. Makes this stuff exciting and interesting. Cool. Until next time, I'm gonna think a little bit about what we're gonna go into. Yeah, I think we're gonna go into like knockback, like the physics of pushing characters back, and potentially launch physics. So we have to implement a whole like reaction that launches into the air, and they're gonna land on the ground and maybe wake up and stuff. Right now we don't have knockdowns, so I might put launching attacks off a little bit until we had like knockdowns. And honestly, knockdowns is when you trip a character, right? That's a whole nother kind of reaction. So that's going to be priority over launch reactions or launch reaction lockdowns, things like that. What is Laguno? Feel free to ask anything actually. We made good time on the stream, so. But if you discuss gun mechanics, I'm not sure what you mean by gun mechanics. I've worked on games with guns in fighting games, but they're pretty much just projectile attacks. Yeah, there's a character I worked on called Arbiter in Killer Instinct. There's Android with kind of a shotgun knee. My character in a game I made called Fearless Knight has a shotgun. A few other has gun attacks, pistols and things like that. Generally, it's just like flavor. You know, the gun, if you want something more like a real gun that has a projectile that travels really fast, and generally you wouldn't do that because you're only updating at 60 FPS, right? So something traveling even remotely close to what you consider a velocity for a real bullet, you might as well do an instant thing, like you say. You can do that, but I think most fighting games have just like a range where they actually hit. If you've seen Elfelt, like she can put her rifle and it's instant. It hits once it's like there's startup to attack like most fighting game attacks, and then once it gets to that startup point, it hits at that location on screen instead of covering a range, right? Like a real gun would do, or something like an FPS. Keep it fair. I mean, fair comes down to a huge range of strengths and weaknesses in a character, right? If you use something super strong in general, there's gonna be some huge downside to it, right? Like if you fire, you have a lot of time to recover it. Like Elfelt's rifle had this mechanic where like it had a lot of recovery, but it had this thing where you can like quickly replace it. It was weird. Unlimited armor, yeah, guns are fair. That's true. Yeah, maybe guns don't cause reactions. It just causes damage. That's actually how it works in most FPSs. You don't actually go through a reaction when you're hit by a gun. You just take damage. You might go make it sound like or something, you know. Ooh. In case of Doom is like yeah, games where I've had guns, they're not instant like that, or they're just very well. Yeah, for us, it's always been kind of like, yeah, there's weakness to it. People without hyper armor kill people. Yeah. Well, I think that's gonna be it. Thank you all for coming by, and really hope to see you here next time. We'll do some knockback physics. Yeah. Well, until then, peace out. Hope you have a good evening if you're out in the U.S. Good morning for all y'all in Europe and Asia. I know it's very early in Europe, but yeah, again, thanks for dropping by. See you soon.